All right, so today we are going to talk about linear and nonlinear functions. So, if linear makes a line, what do you think nonlinear does? Well, not make a line. So we're going to see some things today where we don't have straight lines. We don't have a constant rate of change. We don't have a slope. We don't have a constant ratio. All of those things would mean that it's not linear. Let's check out this example here. The table shows the approximate height and horizontal distance, so height would be height, distance, traveled by a football kicked at an angle of 30 degrees with an initial velocity of 30 yards per second. So that's how fast they kick it. So it kicks high, 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 and then it's going to come down. Did the football travel the same height each half second? So here's our height. So here it traveled 6.2. 6.2 to 9.7 is 3.5. And that's in half a second. Then it only traveled 0.8. So does it travel? No, because the rate of change, or the clock, changes from each half second. Each half second. So really it would just be called a rate of change, or a rock without the C. Okay, next one asks, does the football travel the same length each half second? So if we do the constant rate of change, or the crocodile bumps here it goes 13, 13, 13 for each half second, 13, 13. So yes, the constant rate of change is 13 yards per half second. So this would be the slope, 13 over 0.5, which is actually 26. But that tells us that this is a straight line, because it has a constant rate of change. This is not a line, or we could probably say linear would be better. Linear versus not linear. Okay, now they're going to ask us to graph to kind of prove it. Graph the ordered pairs, time and height, and time and length on separate grids. Connect the points with a straight line or a smooth curve, then compare the graphs. So this is height and time. So height, so 0, 0, a half and 6.2, 1 and 9.7, 1 and a half and 10 and a half, 2 and 8.7. Now we're going back down. 2 and a half and 4.2. So a nice curve. And if we follow that curve, it would probably tell us that the football landed on the ground at about somewhere between 2.5 and 3 seconds. But that one's not linear, it's not a line. This one, we have a 0, 0 with a length, a half and 13, kind of estimating now, 1 and 26, 1 and a half and 39, 2 and 52, 3 or 2 and a half and 65. So that one, if we estimated correctly, does appear to be a straight line. If we could attach it through all the points, that'd be really good. So nonlinear, linear. Nonlinear, linear. Line, not a line, curve. So identify linear and nonlinear function. In a previous lesson, you learned that linear functions have graphs that are straight lines. This is because the rate of change, or the constant rate of change, is between the 2 points is constant. Nonlinear functions are functions whose rate of change are not constant. Therefore, their graphs are not straight lines. They can take on a lot of different forms, but for sure not going to be a straight line. What formula equation have we learned that's always a straight line? Y equals mx plus b. So if something doesn't look like that, do you think it's linear? No. So for instance, if this had like an exponent on it, or exponents, something funny like that, we'll see that on the next slide. Determine whether each table represents a linear or nonlinear function. Remember that linear always has a constant rate of change. So the crocodile bumps are the same every time. So if we check this one and we do our crocodile bumps, 50 to 35 is subtracting 15, subtracting 15, subtracting 15. Now as long as this is the same, 2, 2, 2, which it is, and y over x, remember, constant change y over x is negative 15 over 2. Doesn't simplify, but we could write it as negative 7.5. One of those two options, but this is linear because it has a constant rate of change. Let's check this one out. Crocodile bumps, 2 here, 6 here. That's okay as long as that's different. 8 to 18 is 10. Top, those look like they're all 2's. So because 2 over 2, or y over x, is 2 over 2, and then that's supposed to equal 6 over 2, and that is not true. 1 does not equal 3. This is non-linear because there's no constant rate of change. Word problem. Use the table to determine whether the minimum number of calories a tiger cub should eat is linear function of its age in weeks. So each week, crocodile bumps goes up by 1 week, and its minimum calorie intake, this goes up 175. Now we're up 185. We should already know that since these are different and these are the same, this is a non-linear function, which makes sense that as the tiger gets older, it has to eat more. So that the data makes sense why it would be not linear, why it wouldn't be the same all the time. Let's look at some pictures. Circle all the linear functions. So anything that's a straight line, or anything that's y equals mx plus b. So this one is not a straight line, that's for sure. Y equals mx plus b, so this one would be good. This is not an x squared. This is what screws it up. Y equals mx plus b. X squared again screws it up. Straight line, curve. This is an x squared, so that's definitely not, no curve. A cube has a side length of s meters. A cube has a side length of s meters. So if you draw a cube, remember all sides of the cube are the same. So it has s, s, and s. The volume of the cube is represented by s cubed. The volume of the cube is a function of the side length. Does this situation represent a linear or a nonlinear function? So basically they're asking if the volume equals side cubed, is this going to be a linear function? Is it in y equals mx or y equals mx plus b form? Because of this exponent, that's going to throw it off. This is a non-linear function. It would actually look on a graph, I think it looks something like that. But the point is that this exponent is not the same as an exponent of 1, so therefore it's nonlinear. Every time you see an exponent greater than this 1, you will always have a nonlinear function. Be thankful for what you have. Your life, no matter how bad you think it is someone else's fairy tale. Have a great day.